Hello and welcome back to our next science lesson. Again, still about sound, but this time we're looking at understanding frequency and pitch and what that means to a sound. So, the frequency of a sound is how long the sound wave is. So, from the start of the sound wave all the way through to the second one. Because if it's short, then it's high frequency, the wave happens quickly. If it's long, then the frequency is low because you have a long distance between each one. So in this case, this is our high frequency. You can see the distance between the two bottoms, called a period, between the two troughs, which is the difference, and then the difference here. So the shorter, the more often the wave happens, the longer, the less often. So high frequency and low frequency. Which is that. Okay. The pitch of the sound is how we hear it and whether we hear a high note or a low note. And so a sound with a high frequency will also have a high pitch. So it's quite easy to remember. High frequency, high pitch, low frequency, low pitch. So when you're looking at your waves, if it happens quickly, it will be a high pitch. If it happens slowly, it will be a low pitch. So here's some examples. Have a look at them. 6 sound waves. We're all recorded on an oscilloscope, remember, because the oscilloscope gives us the wave that comes out. Can you describe the sound they're making? And you're thinking about two things: how frequent they are, so that what the pitch is, and how large they are from top to bottom gives you how loud they are. So have a go for me. Okay, so you've got low pitch, loud sound. We've got high pitched, quiet sound. We've just got noise, which is kind of random. There's no real say between them. We've got a low pitch, quiet sound, middle pitch, pleasant sound, and a high pitch, loud sound. Have a think which one relates to which. Okay, so this is our low pitch, loud sound. Big wave, long distances between them. We've got high pitched, quiet sound. So it's often, frequent, but short wave. Sorry, not tall wave. Then we've got noise, which is this random, there's no pattern really. We've got a low pitch, quiet sound, really low pitch, one wave, look, that's spread over distance, but it's not very tall. Then we've got a middle pitch and middle sound. So it's very much not too loud, not too quiet, and the pitch is regular. And then we've got a high pitch because it's frequent with a loud sound. So most sounds are not pure. They are a mixture of frequencies. So the wave on the left is pure sound, a pure note, one note that's continued. And you can see that you get that one wave happening. The wave on the right is more of a jagged, and it shows all the different frequencies within a sound. And this is what sound nearly always is. Every time you hear something or see something, normally it's a mixture of frequencies and your ear picks up all of it. And that creates the sound, or the texture of the sound that we actually hear. Very often you don't hear a very monotone sound, otherwise it gets quite boring. And if someone was to read with you like this, then so what you tend to find is that people's voices, or the sound you hear, tends to be made up of lots of different pitches. And that's what it looks like. And you can see that there are different times, different peaks, different troughs at different times. So a tuning fork is designed to create a pure sound, a single note that you will hear. So if you hit a tuning fork, that you hear is that continuous one sound. Whereas musical instruments don't create pure sounds. As you play them, you are able to mix frequencies in order to make different sounds and different textures of sound that you can hear. And you can see 2 examples, the flute and the violin. The violin having lots of different peaks as it goes through, whereas the flute has that trill at the top. Now you can do this yourself. by creating what's called a bottle orchestra. So you can see, you find small bottles, the more the better. They can be plastic or glass, it doesn't matter. I want you to fill each one with differing amounts of water. So you should be able to put them in order from ones that's not filled very much to ones that are filled the most. And then as you blow across the top of the sound, you might have to angle adjust your angle that you're blowing across it. So the sound that when you're blowing it goes across the top, you'll hear a sound. And as you check each one, you'll see that by changing the amount of water, it will actually change the frequency of the vibration, which will change to the note that's being played. Which one has the higher note? Is it the one with the most water in or the one with the least water in? Could you have a go and see if you could try and play a tune on it? Have a go, see what you can do. Enjoy playing around with your bottle orchestra and just see what notes and what variation in notes you can get. If you had two different bottles with the same amount of water, would the note be the same or the note be different? What do you think? Maybe give it a go, see what you can do. Enjoy playing around with sound and the different frequencies you can make. Remember, high frequency, high pitch, low frequency, low pitch. We'll see you in the next video. Goodbye.